What is cooking, Jaguar students? It's Mr. Allred. We're here together today. I hope you've had a lovely, lovely weekend. Hey, look at that. It's on Thursday. It's Monday. Happy Monday. I hope you've already written tonight's homework in your planner. I hope you've already written today's entry in your table of contents, but if you haven't done so, this is a chance for you to freaking do that right now, okay? Today we're going to talk about slope-intercept form. This is a lovely, lovely way to write an equation that would well tell for us what the graph of a line might look like. Okay, and you'll be able to explain how to write a linear equation in slope-intercept form and then graph it. And you will tell, if you look at this screen, that grammar is very, very hard for me. And that's something that I'm still working through as an adult, trying to understand that the more and more I grow older. But that's besides the point. Okay, we're going to look right here at slope-intercept form. We're going to go and start these notes right now with the Batman soundtrack in the background. So I hope that you are really, really intense and focused on this right now. Okay, when you look at slope-intercept form, okay, we're always going to write equations that look kind of like this. And by kind of, I mean they will look just like this. Okay, they're going to say y equals mx plus b. And we write these equations. These equations are going to be able to tell us they're going to tell us what the graph of a line might look like. They're going to tell us what the graph of a line looks like when we write those equations. I think that after you've looked here today at some of these notes, you might understand what I'm talking about. But this equation will tell us what the graph of a line looks like, and here is the reason. Okay, x and y, those are your variables. Those are your points on the coordinate plane, right? You got x, comma, y. That's any point that's on the line of a given equation, okay? In this particular equation, m represents the slope, and we talked about slope a little bit last week. M represents the slope, and slope, of course, can be defined as rise over run, okay? We also talked about the change in y over the change in x as well. So that's rise over run. We talked about that last Thursday, and then we did that activity with the staircases on Friday to talk about rise over run. B represents the Y-intercept. Okay, that's just a really, really nifty way to say this where the line intersects the Y-axis. Okay, remember the Y-axis is the vertical axis. That's something that you should probably remember. I don't know. That's something that I would probably want you to remember if I were your math teacher. And the good news is that I am your math teacher. So that's something that I'm asking you to remember out of the goodness of my heart. I think it's a good thing to know that the y-axis is definitely the vertical one, right? So you got lots of notes up there, tons of notes. What we're going to do is we're going to take those notes, we're going to apply them to these first two examples, and hopefully that can help, okay? What you can always do is if you're looking at this first example, you can always use the y-intercept as 1 point. Okay, so you're given 1 point. It says b equals 0, -4. Remember that b is the y-intercept. So this is me telling you, hey, this line actually intersects at 0, -4. It intersects the y-axis right there. Okay, then we can use our slope. It says 1/2. We can use our slope to actually draw a point that we can then draw a line through. So if I know the rise over the run is 1/2, I can use the point I already have, and I can go up 1 and over +2. This represents up 1 and over +2 from the point I already have. I can use that to then actually draw a line between those 2 points. I can use that to then draw a line between those 2 points, okay? And your line doesn't have to be perfect, but it can be perfect like mine is, right? It just doesn't have to be perfect like mine is, okay? But it totally can be, okay? What you can see is we actually now have a line. We use the y-intercept and we use the slope to draw that line, okay? And from that, we can actually write an equation that says y equals 1/2 x plus -4. This is an equation in the form y equals mx plus b, okay? I just use that form to write an equation like the one that you see up there in blue, y equals 1/2 x, that represents the slope times x plus the y-intercept. And that's the first equation that you've ever seen in your whole life in slope-intercept form, and you can use that to apply it to the rest of these examples, okay? I hope that example made a little bit of sense to you. If it didn't, we're going to look here at the next example, number 2. It says m equals -1/4, and it says b equals 0, 3. So the y-intercept here is at +3. Okay, that's where the y-intercept of this line is. It's at +3. I can tell that because it says it on my page, but I also, can tell that because I have a good math teacher, and he told me that the y-axis is the vertical one. So I can look here at 0, 3, and I can draw my first point. Based off that, I'm going to draw a point right here at 0, 3. There's my dot. Okay, if I were to use that slope, -1/4, I need to make sure that I have a negative line. Okay, you can do this a couple ways. I'm going to go down 1 and then right 4. I'm going to go 1, 2, 3, 4 to the right, and then I'm going to draw my point right here. Okay, let's say that you had gone up 1 first. You will make sure you went left 4 times. 1, 2, 3, 4. That would mean that you at least did one thing in the negative direction, and that would make sure for you that you actually drew a negative slope. Remember that we said negative sloped lines, they go down from left to right. So you want to make sure that you drew a line that went down from left to right when you're trying to draw a negative slope there. Okay, so what I have for you here is I just have a line. Okay, I have a line that goes through the y-axis at +3, and it has a slope of -1/4. I'm going to call this line y equals -1/4 x plus 3. That's my y-intercept and my slope in slope-intercept form there on the paper for you on the screen. Okay, a couple things here for these first 2 examples. Okay, for the rest of these examples today, I'm going to give you the slope, I'm going to give you the y-intercept, I'm going to ask you to write an equation and draw a line. Those are 2 things that I definitely need you to do. Okay, for example, if you look here at this third example, you can know a couple things off the bat. The slope is -3. The y-intercept is +6. So the first thing you're going to want to do is you're going to want to use the y-intercept as 1 point. That's just going to help you out to start that problem. So if you use the y-intercept as 1 point there for number 3, I want you to pause your video, and I want you to put a point at 0, 6 there on your page. Pause your video, dang it, right now. Thanks for doing that. I appreciate it. I hope that you drew a point at 0, 6, and I hope you drew it right here. Hope it's where you drew your point. Okay? If we had a slope of -3 there, that means the rise over run is like -3 over 1. Think about it that way. That's the rise over the run. The slope there would be -3 over 1. Make sure you actually include that 1 so you don't have just a freaking vertical line on your paper there. But if you went down 3, 1, 2, 3, and over to the right 1, that would give you a negative slope, and you might have a line that looks kind of like, maybe exactly like this there on your screen. Maybe that's what your line looks like. Okay. Maybe that's what your line looks like. But you might have a slope of -3 with the point of the y-axis at 6. Your equation might say y equals -3x plus 6. That would be our equation in slope-intercept form there for number 3. I hope these examples have helped a little bit. If they haven't, I apologize for that. I really am truly sorry for that. Hope you can ask your partner. Maybe they can help you explain it to you a little bit better. Okay. Remember always to stay classy, not trashy. And remember that of all my students that I've ever taught in my whole life, you are one of them. Have a great day. Make it a great day or not. The choice is yours. Appreciate it. Goodbye.